Hello, I'm Michael Parker, and welcome to Antidote. For the past year, the words El Nino has been on everyone's lip and all through the news. But if you live here in Southern California, you might be asking yourself, where's my El Nino, yo? Well, here to explain it to us what El Nino is, what it is not, and what we can expect for the remainder of the El Nino season is Tom Di Liberto. He is a meteorologist with NOAA, which is the National Oceanic and Atmospheric Administration, and he is part of their Climate Prediction Center. Tom, welcome to Antidote.
Thank you for having me.
So Tom, I kind of say this in jest, but I know that a lot of people, well, even the LA Times yesterday said, where is El Nino? So first of all, let's kind of explain to people what El Nino's not. El Nino's not a storm.
Nope, El Nino's here. El Nino's been here since March. It just whether it impacts the United States is a whole different question. So El Nino actually refers to an anomalous warming of the central and eastern Pacific Ocean along the equator, and it subsequently kind of impacts the atmosphere above it, and through a bunch of dominoes fallings can impact weather we see across the United States. But El Nino's here. Whether it impacts us in the United States is a whole different question.
So El Nino is this complex interaction between oceanic aspects and atmospheric aspects. It's not something that ever breaks landfall. It's all happening above the ocean, above and below the ocean.
Right. It's not, basically I like to think of it as that El Nino sort of sets up it builds the railroad tracks for storms into the United States. It helps to kind of point to storms where they should go. It's not the actual storm. It just kind of sets up what the situation looks like. And because of that, there's all sorts of other things that can kind of get in the way. You can kind of see that impacts change a little bit on a week-to-week basis here in the United States. But no, El Nino is not a storm. It's not going to hit per se. And it's been here. And yeah, as you mentioned, it's very complex relationship, a push and pull between the oceans and the atmospheres in the tropical Pacific Ocean that can affect globally weather conditions really, really far away from where that warming is in the equatorial Pacific Ocean.
If we could bring up a picture of one of these thermal images of El Nino, because these have been out in the press for quite a bit, and you can see this yellow image, this yellow area near the equator, actually below the equator, I suppose, off of Peru, that is the El Nino waters. So Tom, explain to us, how do these waters get warmed? Because if I'm understanding correctly, the oceans themselves are warming, so why does this particular band get warmer?
That's a great question. So in the tropics in the Pacific Ocean, there's something called the trade winds, which basically blow from east to west across the Pacific Ocean. So if you imagine the Pacific Ocean as a bathtub and you have basically winds blowing in one direction across the bathtub, if you took a look at the sea level height in the Pacific Ocean, the western Pacific Ocean is actually higher than the eastern Pacific Ocean. So as you blow that water from the east to the west, it warms the entire way. And what happens is normally in the western Pacific Ocean, near Indonesia, the Philippines, and in that region of the world, the waters are actually warmer than they are off the coast of Central America and South America. That's normal. During El Nino, what happens is that those winds that blow east to west, they break down. They either really weaken or actually reverse themselves and blow the complete opposite direction. And what that does is it lets all of that warm water that's pooled up in the western Pacific Ocean begin to slosh back to the east. And when it begins to slosh back to the east, it has a ton of ramifications for what the atmosphere above that water actually does.
So in some ways as well, this is a massive transfer of energy.
Exactly. It's very much so. So normally in Indonesia and in that region of the world, there's lots of thunderstorms because in really wet conditions, because the water is wet and you have all this rising air, which leads to thunderstorms. During El Nino, what happens is as that warm water moves to the central Pacific Ocean, the thunderstorms kind of go with it. So usually now where there used to be thunderstorms, they find a lack of thunderstorms or less precipitation. So we normally see drought in that part of the world. And when you move those thunderstorms and the rainfall and that into the central Pacific Ocean, it basically changes the entire atmospheric circulation along the equator. And that is what we refer to as the El Nino here. It's that moving of the warm water to the east, as well as the subsequent jumble up of all the atmospheric circulation that we normally see along the equator, and that then has huge impacts to where the jet stream is located, for instance, across the United States. And the jet stream is just that area high up in the atmosphere of fast-moving winds that kind of serves as that highway for storms to kind of travel along.
So there's been a lot of comparison of this particular El Nino to the 1997-98 El Nino. And I guess what I'm wondering is, because that was, correct me if I'm wrong, viewed by many to be the largest El Nino on record. If this one's being compared to that, is this current El Nino behaving in a manner that was predicted by all of you guys?
So this event, I would say, is a top 3 event along the likes of 1997-98 and 1982-83. Those, before this year, those two, if you look back at the pantheon of El Nino events, those two were very firmly there as number 1 and 2. And this event is joining that pantheon, that top 3 event. Now, there's a lot of different ways you can measure how strong El Nino is, which is why I'm not going to say it's the strongest ever or number 2 or number 3. But the fact that I'm even talking about it in the same sentence as 1997, 98, and 82, 83 is significant. These events do not happen that often. And the question is, what type of impacts do they have? That's the big question, especially for the United States. Are we going to see similar type of impacts during the winter time that we saw in 1997 occur this year in 2015? And while, we always say El Nino's one major impact of seasonal precipitation and temperature across the United States, it's not the only thing. But with that said, we have seen at least some pretty consistent patterns that we expect to see during El Nino show up across the United States. But no 2 El Ninos are alike, and no 2 impacts to the United States will be alike either. So there always are going to be some wrinkles that Mother Nature throws in that kind of changes things up to what we actually expected to happen.
I have been learning a lot about El Nino in preparation for this show, and I've seen several people say that, El Nino and La Niñas are very predictable. Yet 2014 was supposed to be a major El Nino, and it just didn't pan out.
So, right, in 2014 was a very interesting event. Now, we at the CPC, we didn't predict it to be a major El Nino. We did predict it to be, at least probability-wise, to be an El Nino, and it just didn't take. It was really interesting, actually, from a scientific standpoint, although, if I wanted my forecast to verify, I would have preferred it becoming an El Nino. But it was interesting because the waters in the central and eastern Pacific Ocean looked very much like El Nino. They looked like it was a very borderline weak El Nino, but an El Nino nevertheless. The problem was that the atmosphere reacted like there was no El Nino there. There was no coupling between the ocean and the atmosphere. So we only really had 1/2 of what we needed for declaring an El Nino. And this year was the complete opposite. We've basically seen the waters warm up. We've seen the atmosphere react exactly the way we expected the atmosphere to react. So it's been basically what you normally expect to see during El Nino. But you can certainly say we had a little bit of a false start in 2014. That was very interesting.
So in 2014, one of the primary reasons that it didn't end up panning out was because the westerly winds didn't crank like they were supposed to?
Right, that's exactly right. So basically we saw the ocean warm, but we didn't really see the response in those trade winds and at upper levels that we'd normally expect to see. So we've had this big sloshing of warm water kind of move from the west to the east. It moved from the west to the east in the Pacific Ocean. But we didn't really see the winds really respond the way we would expect them to. We didn't really see that moving of convection further off to the east, thunderstorms to the east that we expected it to. We basically just kind of saw it, just the ocean respond and not so much the atmosphere. But 2015 showed none of that and basically just saw that exactly what you'd expect to see during El Nino, and we've been seeing it strengthen all the way back since we declared El Nino here in March of 2015.
One of the other things I've been reading is that El Nino appears, in periods of 2 to 7 years. So I guess when I'm looking at graphs that show El Ninos versus La Niñas, and La Niñas are kind of the opposite, where you have the cooler water, is that right?
That's exactly right.
Okay, so I guess one of the things that I'm wondering is if 2014 didn't pan out, it looked like it was going to be similar to 97. It started out with some of the same diagnostics as 97, but it didn't work out. Does that add to, is that a bit of a cumulative effect, adding to the probability that 2015 was going to be this large El Nino event?
That's a great question. And certainly this event started at a warmer standpoint than you'd normally expect to see an El Nino start. And when I say that, that's because we had this failed El Nino in 2014. So the waters actually already were slightly above average in the Pacific Ocean, but they weren't up the El Nino standards. It kind of helped out basically the beginning of it. But, there's a lot of other things that go on, not necessarily because we had a 2014 failed event necessarily mean that 2015 was going to be a super event, a really strong event. We basically here at CPC, we only classify it as weak, moderate, and strong. But when we're talking top 3 event, just because we had this failed event in 2014, it didn't really give us too much information that 2015 was necessarily going to be a top 3 event. But it may have helped us out to know at least that maybe 2015 would have formed an El Nino itself. But not at least not telling us too much about the strength of the event as it ended up being.
I understand. And the water temperature changes in an El Nino event. What are we talking about? What is the mean temperature that we would look at to create these types of conditions?
So when we define an El Nino event occurring, we're looking at a very specific region in the Pacific Ocean, not the entire Pacific Ocean. A Pacific region that's basically honestly, it's kind of in the middle of nowhere in the Pacific Ocean. It's called the Niño 3.4 region. It spans a pretty broad area between 5 north and 5 south along the equator. And that area was chosen because that specific area kind of perfectly exemplifies where we would expect to see above average sea surface temperatures during El Nino, and also where, if we kind of looked at weather conditions in the United States during El Nino and areas in the Pacific Ocean, they kind of correlate the best to each other. When one thing changes in the Niño 3.4 region, you tend to see the biggest El Nino impacts in the United States. So because of that, the temperatures there, we define El Nino as occurring when temperatures in that box are greater than 0.5 degrees Celsius over a 3-month period, as long as an expectation that we think that this is going to continue for quite a while, over 5 consecutive 3-month periods. And we define a weak event as 0.5 to 1 degree Celsius, and then a strong event above 1.5 degrees Celsius. And right now, this event is over 2 degrees Celsius. In a place where really only 97, 98 and the peak of 1982, 83 ever came close to touching in that region.
So I thought that I read that in December at one point the degrees even exceeded 3 degrees. Is that correct?
It depends on which data set you use. One of the benefits of living in modern day is that we have lots of things looking at other things across the globe. We have satellite data sets that look at sea surface temperatures. We have observational data sets that use buoys and use ships to figure out the ocean temperatures. And depending on which data set you use, you'll get different total numbers. But there's ranges. I wouldn't take any number as gospel because no matter which way you try to measure, you're never going to get a perfect sampling of the Pacific Ocean because it's so big. And there's not too much out there to measure. But certainly we've set monthly records in that region in a variety of data sets. We've set weekly records in a variety of data sets for strongest ocean temperature. So we're certainly seeing an event again, as I mentioned, that the likes of which we do not see that often.
You brought up the mention of these buoys, and I was really fascinated about this. If we could bring up some photos of this, I'd like to show folks this TAO array, which is the Tropical Atmosphere Ocean Projects. Explain how this works and how these buoys work and how many of them are there.
Well, there's a good amount of buoys, and they're kind of situated, you can think north-south along the equator. And if you think about it, it's only until recently we've had the amount of observations possible across the Pacific Ocean. If you go back before 1950, you would only have a couple of ship tracks that would move through the area, and it wouldn't be happening all the time, and it'd be very difficult to exactly figure out what's going on. But now we have at least this TAO buoy array set up across the Pacific Ocean, which gives us a whole bunch of different type of data to look at. We have sea surface temperature, salinity, all the sea level height. We have all these different aspects which we can look at in real time that we then use also to create a globe, or at least a data set, a gridded sea surface temperature data set over that entire region. So previously we'd have to rely on other things or the occasional strip, but the Tau buoy itself is so useful because it basically gives us that data in the field, in the Pacific Ocean, where we expect to see El Nino, and it gives us actual numbers. We don't have to try and derive it from satellites or figure it out from the models. We have an actual number for how warm the sea surface is in that region of the globe, and that basically helps us get an idea of how well all the other data sets are doing, or how well the models are doing in capturing that event. It's a really vital data set, an array that we have across the Pacific Ocean.
Is this an international situation? Did we have assistance in creating this, or is this purely an American thing?
I believe we had international assistance. The one interesting thing with El Nino is, El Nino is such a global phenomenon. It impacts so many places across the globe. And I know we here in the United States, we do work with, we all make our own independent forecasters, but we talk to the forecasters in Australia, we talk to the forecasters in Peru, places that can really be impacted by El Nino, who make their own forecasts up. And it's really a global community because we're all trying to figure out what is going to occur with El Nino, because we know the impacts are going to be felt in a lot of places, and in some cases pretty drastically across the globe.
Well, you bring up the global effects. I was going to ask you, so far for this El Nino that we've had, now here in Southern California, we've only had 1 week of rains that were directly attributable to El Nino. Now, I was looking at some other materials, and it seems like in South Asia, their monsoon season they're getting less rainfall than usual, and parts of Southeast Asia are experiencing droughts. Right.
So you can kind of think of it as kind of a tiered system in terms of impacts with El Nino. The closer you are to the tropical Pacific, the more likely you're going to see a pretty standard impact. The further you are away in the mid-latitudes where we live, you kind of have to rely on a cascade of events to kind of see those impacts. So you're right. In Southeast Asia, it's been very dry. We've seen a good amount of forest fires and wildfires develop over that area. A lot of pollution from that, reducing visibility across a lot of major cities in that region. Meanwhile, Australia actually usually tends to see certain conditions as well, but they've actually not seen as much impact that they would normally expect to see during El Nino, because the waters around Australia are abnormally warm, which is kind of counteracting some of the impacts from El Nino. But you're right. In Southern California, you've basically over the last 30 days had average rainfall, which is good considering how dry it's been over the last 4 years. But certainly when you hear El Nino and you think about California, you think, oh, that means a lot of rainfall for Southern California. We're still early in the season. We still have until really March, I would say. January, February, March is really a prime time to see a lot of rainfall. So it's still early. There's still a chance that we could see a good amount of rainfall. But, it shows you how, while we have this big event happening in the Pacific Ocean, weather still goes on in the United States. And there are other things that could necessarily impact where that rain ends up being. And right now, it seems like all of that rain has been pointing more towards Northern California and not so much Southern California so far.
And this is where it gets interesting to me, because when I look at 97, 98, which, I was here in LA at that point, and I don't really remember being inconvenienced by weather at that time, but certainly the records show that we got an extraordinary amount of rain. And what's interesting to me is if this one turns out to be like that, then yes, all of the big rain is ahead of us in February and March.
Right. I mean, the most recent seasonal forecast that we issued at the Climate Prediction Center basically says that there's a decent tilt in the odds towards it still being a very wet, or at least wetter than average, January through March. That's still expected to happen. So you could still potentially see a good amount of rainfall falling, and just climatologically, the way we normally see things with El Nino, that's generally the case. Of course, just because it happens in the past doesn't necessarily mean it's going to happen in the future, which is why there's always a risk that it won't. But there still is a tilt in those odds towards it being wetter than average over the next 3 months. So just because we haven't seen as much as you expected per se so far, doesn't necessarily mean that the rest of the season won't be wet. We haven't gotten to that part yet, and we'll have to play that more closer to the when we actually see those storms kind of moving on shore, thanks to that extended jet stream, thanks to El Nino. But there's still plenty of time for rainfall for California and Southern California.
That is good news because we certainly need it. And one of the, I think, misconceptions about El Nino is the term gets applied to so many different things. I saw something on the Weather Channel recently where there's even like a Blame El Nino Snapchat app or something. And so everybody is associating El Nino with a lot of things that aren't actually associated with El Nino. And you mentioned the rainfall in Northern California that we're receiving. Now, some of that is just typical California winter rainfall.
Sure, right. And honestly, it's very difficult to say when it rains during the usual rainy season for California, whether that drop or another drop was like, oh, that drop was thanks to El Nino, but that other drop was natural. It's really hard to kind of figure out exactly that sort of attribution that we have to expect to see, which is why when we talk about El Nino, we're looking at the seasonal average and not individual events, because you're right. It should rain in California. I know it hasn't rained a lot in the last 4 years, but normally it should rain during this time. So in December, there was other kind of atmospheric kind of events going on, which led to heavier rainfall across the Pacific Northwest and Northern California that I would probably say were more due to other things than El Nino. But recently, we've kind of seen, this extended jet stream that we normally see during El Nino. It just happens to be pointed a little bit further north than you normally see during El Nino. So you can see there's at least the rainfall we're seeing is consistent with what we'd see with El Nino. But kind of figuring out which is El Nino, which is not, is too difficult to say.
At one point in 97 or 98, I believe there was one storm off of central Mexico that dropped like 27 inches of rain in one night.
Wow. That's a lot of rainfall. And that's one of the things that we're trying to communicate too, is that, El Nino tends to have implications for California that might kind of be weather whiplash to Californians, where they've experiencing such drought over the last 4 years. But when you usually have El Nino, you see heavy rainfall that falls all at once, and that leads to mudslides. That leads to flash flooding. And one of the kind of not great impacts due to how dry it's been is that the drier the ground is, it usually means that the less capability it has to absorb water as fast as just a regularly saturated ground. So what happens is that rain will fall on that ground and end up just washing away, which leads to mudslides and again landslides. So that still is a possibility with El Nino. With strong El Nino events, we've seen pretty big impacts in California in the past, and that is still certainly a possibility as we move through the rest of this winter.
That was a primary cause of the damage in 97 and 98 out here. Now, this winter storm that you're facing on the East Coast, I know that you're in Washington, D.C., is this winter storm in any way related to El Nino, or is this a separate system entirely?
Probably not.
Okay.
It's harder for a signal for the Northeast and getting into the Mid-Atlantic during El Nino. Basically, what that means is that in past years when we've had El Nino, the weather has kind of done a whole bunch of different things. So the signal, honestly, is clearest across Southern California and actually across the Gulf states, where we've seen a wetter than average signal, and that's what we normally expect to see during El Nino. But whether these storms, it's probably too difficult to say whether this is just kind of normal winter snowstorm here that could occur any year necessarily versus any sort of El Nino impact.
You mentioned the Gulf states. Yes, I mean, states like Texas, Louisiana, Oklahoma, in that general area, those guys have been hammered with rain over the last year and a half or so.
Right. And in fact, we've seen the Mississippi flood across a good portion of it in December and January. And that's very odd because they usually don't see their flooding until the spring. It's very abnormal to see that flood during the end of the year and the beginning, basically over the winter time. And they've seen some very heavy rainfall across, as you said, Texas, into Louisiana, even further north into Missouri and Arkansas. We've seen some very heavy rainfall. And that is all somewhat consistent with what we'd expect to see during El Nino, during the winter time.
One last thing I want to ask you about is how El Nino affects the ecosystem that is the ocean, where you talk about the fisheries and the various algae and the coral bleaching. Explain a couple, because you have a great blog, which we're going to put a link to below the show when we're finished.
Thank you.
Tell us a little bit about how this affects coral and algae blooms and fish.
Well, earlier this year, they declared a global bleaching event, the first time that has happened since the 1997 timeframe. And basically what happens is it means that the oceans are so warm that it's too warm for the corals to survive, and they end up dying out. We tend to see that across the Pacific Ocean. But honestly, the globally speaking, even off the Pacific Ocean, the oceans have been very warm this year, and that doesn't necessarily have anything to do with El Nino. So it's been a very warm year for the ocean, which could have, as you mentioned, major impacts for coral as well as fisheries in areas like the Galapagos Islands, where when you have warmer than average waters near the Galapagos, for instance, it keeps all that nutrient-rich cold water away, and that cold nutrient-rich water is what animals eat. And when you basically shut that off, you're basically saying, sorry animals, we don't have as much food for you to eat. So we tend to see big impacts to wildlife across the Galapagos during El Ninos, as well as fisheries off the coast of South America, which rely on that colder water to feed on all the nutrients. And during El Nino, it's kind of shut off, and that has major impacts for not only the oceans but also the economies that rely on those oceans for sustenance and for jobs.
And recently, we've had reports, especially I believe around Long Beach, and they've had these strange snakes that would wash up. So like unusual animals that you don't see in these particular waters are kind of coming this way. Did they just get discombobulated by the temperature change?
Right. I mean, they're used to living in a certain temperature water, and if that water is now abnormally warm off the coast of California, you might see animals move to places where they don't normally move before because of just how abnormally warm it is. We do tend to see that with El Nino.
All right. Well, Tom, I appreciate you spending some time with us. Here in California, we definitely need that water. And from what I understand, we would need several El Ninos to get back to the place that we would like to be. But thank you for spending time with us, and thank you for explaining this.
Thank you for having me. It was good talk.
All right. Ladies and gentlemen, my name is Michael Parker. This has been Antidote. We were talking about El Nino. I'm still waiting on the rain, and we've had a little bit. Hopefully we'll get some more. Until next week, you, me, every single one of us, we are the Antidote.